Exercise 2E polygon notes. This one arguably would be one of the easier ones. Your hardest one is exercise 2B. So if you've done 2C, 2D, you'll find 2E pretty easy as well. If you haven't done them, make sure to do 2C and D before next week. Here we go, polygons. What is a polygon? They are shapes with, fill this in, straight sides. Okay, so a circle is not a polygon because it's curved. So any shape that is a minimum of 3 sides, okay, because if you just had 2 sides, it's not a shape, it's an angle, right? You create an angle. So minimum is 3, we call that a triangle, right? So 3, we call that a triangle. 4 sides, so 4 straight sides together, that's what we call quadrilateral, which is 2D. So 2C, 2D, and then now all of these shapes here, these are the names you must know. So one of the first skills in exercise 2E is you have to be able to identify. If it's 5 sides, we call it pentagon. 6 sides is hexagon. 7, I find students tend to forget. It's heptagon. 8 students know. 9, they forget. Sometimes they remember 10, and definitely they do not remember 11 and 12. That's on your sheet, so memorize these ones so that you know the names. If they come up on the test, which likely it will, you need to know how to name them. Okay? What's the difference between just a polygon versus regular polygons? Well, they have the sides of equal length and equal interior angles. What does that mean? Here's a typical one. Hexagon. When I say hexagon, most of you are likely thinking of this shape. 1, 2, 3, 4, 5, 6. Yeah? When I say hexagon, you're likely thinking of that shape, which is the one that is on your soccer ball, right? Or those little shapes that you play around with and you connect them together. That's called a regular hexagon because all sides are equal length. That means all angles are also equal. But a hexagon doesn't have to look like that. Hexagon, which is a polygon, just means it's a straight side with 6 sides. But I can draw 6 sides not like that. I can draw it like this. 1, 2, 3, 4, 5, 6. That's a hexagon. Nothing wrong with it. So when you say a hexagon, this is what a hexagon looks like. That's 1, 2, 3, 4, 5, 6. This is also 1, 2, 3, 4, 5, 6. But the one that you're thinking of is actually called a regular polygon. So regular hexagon, a normal, that's just a hexagon. Okay, so I'm going to write on the side so you remember. This is hexagon. This is regular hexagon. So when you see the word regular, it implies that all sides are going to be the same and all angles are going to be the same. If they don't say regular, it means it can just be any angles for each corner. Every corner is different and it just has 6 sides. That's why it's called a hexagon. Okay? All right. Now, there is a pattern that you need to take out. So first skill was identify. So name the shapes based on the number of sides. Number 2, let's go back to our understanding of 2C and 2D. If you add all the interior angles, so all the angles inside a triangle, so these are called interior angles. If you add them all together, what must it equal to again? 180. So it's 180 degrees for a triangle. Then you do 2D, quadrilateral, if you add all the interior angles of a 4-sided shape. All the inside angles must add up to 360. Now, one of the reasonings is because if you cut this quadrilateral from corner to corner, if I cut it like this, I'll do it again. If you cut it like this, you end up with 2 triangles. So that means this part of the corner, so from here to here, plus this part of the corner, plus this part of the corner, that's a triangle. You told me that the angles in a triangle must add up to 180. So that means, so far, I've got 180 degrees adding these 3 corners. But then if you add the leftover corners, so I'll highlight in yellow, this corner on the top, this corner, and this corner, that makes up all the 4 corners, blue and yellow together, another 180. That's why 180 plus 180 gives you 360. Now here's one that I think students don't truly understand why it works. I'm going to give you one as an example. Let's go with a pentagon. Now pentagon, there's two ways of drawing this. So if I'm saying that the more triangles you can cut, then you can work out the total angle, right? So a pentagon has 1, 2, 3, 4, 5. 5 sides. If I cut it up from corner to corner, so here's one, corner to corner, that's one triangle. So that one should add up to 180. I do another corner to corner, so from this corner to this corner now, that's 1, 2, 3 triangles, right? If each one is 180, 180 plus 180 is 360, plus another 180 gives you what? 540. So you can say that all the corner angles added together should equal to 540 degrees for a pentagon. But what if I did this? What if I draw a pentagon again? I do corner to corner. Whoops. Corner to corner, corner to corner. Now you got 1, 2, 3, 4. Or you could count it as, 1, 2, 3, 4, 5. 5 triangles. Can I say 1, 2, 3, 4? Can I say now 5 triangles times 180, because each one's 180 degrees. 180, 180, 180, 180, and then 180 again here. Can I say 5 times 180, which is, what is that? 0, 4, so 900 degrees. Which one's correct? Well, they're both incorrect. Hands up for both of them are incorrect. Hands up for one of them is correct. Hands up for 540 being correct. Hands up for 900 being correct. Okay, so most of us think it's 540. The answer is definitely 540, but I'm more interested, why is this one wrong? Because we talked about triangles, I drew my triangles. What's the problem? Ask Leah.
There's like a missing shape in the middle, which you need to also add as well, or else it won't be like a full shape.
Ah, okay, yes, that is one of the reasons. Yes?
The entire shape has to be in the triangle, because then you could just draw like 10 triangles inside the shape and just say it's like.
Oh, that's a good point. Now let's test that theory then. Let's draw a hexagon now. 1, 2, 3, 4, 5, 6. If I do a corner to corner, so one corner to corner, 2, 3. So corner to corner, corner to corner, corner to corner. How many triangles do I have now? I got 4. So 1, 2, 3, 4. So you would say 4 times 180 degrees gives you 720. Well, let's draw the same shape again. 1, 2, 3, 4, 5, 6. Let's do it this way now. I'm going to do 1, 2, 3, 4, 5. Now they're all triangles. Let's count. Actually, they're not all triangles. What? Let's do... How else can I do it? I can do it... Does that work? Yes. 1, 2, 3, 4, 5, 6. I now have 6 triangles. Not like the first one before. I have 6 triangles now. 6 times 180 is equal to 0, 8, 4, and then 6, so 1080 degrees. Are they both incorrect? One correct? What's going on?
Can I say the answer?
Yeah?
The lines can't cross over each other.
Ooh. Why? Yeah. This is one of the reasoning questions. So I'm trying to get you guys to think. So when you do the reasoning, one of them is asking this theory, because there's only one correct answer. For some students will do it like this. And if I say every time you get a triangle, it's 180 each, well, why can't this be right? Because I've got 1, 2, 3, 4, 5, 6 triangles. Why does it not have to intersect? There's a reasoning to it. I want to understand why.
Because then you're making a triangle smaller sometimes, and it's two for no reason.
It's a good reasoning point, but that's not why it is.
Maybe because you're basically making your own shape.
It is because you're making your own shape. But I want a mathematical reasoning, because what are we looking out for again? What are we trying to find the sum of? What's the point? What was our purpose to begin with? What are we trying to add or find?
You're making angles for no reason.
Well, you do need angles to begin with, but what type of angles are we looking for? Which corners are we looking at? Because if you look at exactly what we've been trying to do, you'll figure out why this works and what doesn't make sense. Which is what Arman was saying. You can't intersect. There's a reason why we don't do that intersection. Interior. Okay, good. Now, think about what they just said there. The language when we say triangles, you guys keep thinking triangles. 1, 2, 3, 4, and you just think 180 plus 180 plus 180 plus 180, but it's not that. See, when we say triangles, what we're actually trying to calculate, remember, was the corner angles. This corner plus 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 this corner. All of those interior angles will tell you the sum. That's what we're trying to look for, right? What's the problem when you do it this way? See, this is one corner, one corner, one corner in a triangle, but you see this angle here? That's not even part of the hexagon. See, if I do it again. Yeah, I'll do it over here. This corner, this corner, this corner. That's 3 angles to make a triangle. Yes, it's 180. But can you see that little bit in the center? These angles is not even part of the hexagon. Get me? Whereas this one, all of it is part of the hexagon. This triangle, this corner, that's part of the corners. And then if you look at this one, this is still part of that corner. This is still part of this corner. And this is still part of this corner. That's why every corner of these triangles, when you add them, it makes sense. It's 180, 180. The corner of this plus the corner of this plus the corner of this is 180. The corner of this plus this corner is also 180. That's why it's 4 times 180. Okay, I'll draw it again so it makes sense to you. So this is what our goal was. Don't forget the goal. The goal was to find the sum of all these angles. There's only 6 of them. But when you split it, can you see if I split it like this, that angle is just split up into 2 bits. I'm still calculating these 2. When I split this one over here, that's still part of the 3 angle arc here. It's just split into 3. I've just got 3 of them. So it's still, all these 2 triangles are still made up in these corners. But if you did it this way, 1, 2, 3, 4, 5, 6, here's the problem. If these are the corners that you're trying to find, but I draw it like this now. I draw it like 1. Oh, sorry, it was this way. I did it like this. 1, 2, 3. Can you see that triangle there? Yes. You have this bit, but then suddenly the triangle has this corner. That doesn't tell me anything. This plus this plus this. Yes, that equals 180. Well, what's this bit telling me? Tells me nothing of the hexagon. That's where Will was saying, adding angles for no reason. So that's true. Okay, so what you guys are saying is true, but what's the goal? The goal was to find the angles on each corner. So that's why when you draw the triangles, you're trying to make sure each triangle that you do has connections to each of the corners. That's when it works. Now, that's the reasoning. If you do the reasoning question, that's the reason for it. So if you're questioning it, that's what it is. Now going back, let's say you didn't understand what I just said. You're like, oh my God, what he just described is so confusing. Then I just want you to see a pattern then. Here's a pattern. When you had 3 sides, you had 1 triangle, so it's 180 degrees. 4 sides, you ended up with 2 triangles and you had 360 degrees. So I'll draw it over here. So you can see you got 2 triangles there. So 4 sides makes 2 triangles. 5 sides, a pentagon, has 1, 2, 3 triangles. So here we go. Let's fill it in. 1, 2, 3. You got 3 triangles. 3 times 5 gets you 540 degrees. Now, if you look at a 6-sided shape, which is the one I showed you before, This one has 1, 2, 3, 4. 1, 2, 3, 4 triangles. And 4 times 180 is 720 degrees. Do you guys see a pattern? What's the pattern for the number of sides? So notice this is going from 3. If it's 3 sides, you get 1 triangle. 4 sides, you get 2 triangles. 5 sides, you get 3 triangles. 6 sides, you get 4 triangles. What's the pattern? Will?
Every extra side added is one more triangle, which means 180 more degrees.
Very good. So if you have 7 sides, how many triangles? 5. Now let's test your understanding. What if I said I had 99 sides? How many triangles? How do you know?
Because it's always 2 less.
It's always 2 less. Have you noticed the pattern? 3 minus 2 is 1. 4 minus 2 is 2. 5 minus 2 is 3. There's a pattern. They're all minusing by 2. The number of sides in a shape or polygon, if you subtract 2, tells you the number of triangles. So that's the pattern that they figured out. And they said, oh, well, in that case, let's make a rule. If you know the number of triangles, all you do is times it by 180 to know the total sum. So here's the rule. Total angle sum. This is called total angle sum. Total angle sum is number of sides, take away 2, because you're always 2 less. That will tell you number of triangles. Once you know the number of triangles, times by 180, because every triangle has 180 degrees. This is the rule so that you can work out for a 9-sided shape or a 99-sided shape, you would know how to figure out the rule. So here's an example. If I told you that we have a 100-sided shape, actually 102, let's make it 102. What should all the angles add up to? So there's 102 sides, so 102 corners. If you add them all together, what should it equal to? How would we work this out? Losalia.
Minus it by 2 should be 100 triangles, and then times it by 180 would be 18,000.
Beautiful. Do you see that? Because you know it's 102 sides. If I ask you how many triangles there should be, minus 2 from it. So there should be 100 triangles. If there's 100 triangles, 100 times 180, 18,000 degrees. So if you add all of them together, if we can draw a 102-sided shape, all the corners should add up to 18,000 degrees. That is one of the skills that you need to know for 2E. Okay, so you didn't have to just do triangles for 2C. 2D was just quadrilaterals. 2E now is just saying, what if I got a 5-sided, 10-sided, 20-sided shape? What would the total angles be? And you have a formula to figure it out. The formula was just made from looking at a pattern. Okay? All right, let's do an example together so you get a vibe. Here we go. Flip over the page. Let's do this question. Example 2. I'm skipping the example 1 because you guys should be able to figure out octagon now. Here we go. Find the value of A in the hexagon. Now, based on what we've talked so far, hexagon. How many sides does a hexagon have? Let's go with Oliver. 6. Very good. Which has 1, 2, 3, 4, 5, 6. Now, what should the angles all add up to in a hexagon? Now, you can memorize it or you can solve for it. Anyone remember what the angle should be? 720. Let's prove it. The rule was n minus 2 times 180. N is the number of sides the shape has. We clearly have 6 sides, so it should be 6, take away 2. That tells you the number of triangles. So you got 4 triangles, and 4 times 180 is 720 degrees. So what this means is if you add all these corners together in that 6-sided shape, it should equal to 720. Now the angles that we have, what's this little box mean again? 90. So I've got 90 degrees plus 90. So let's write it down. We've got 90 plus 90 plus 150 plus 120 plus 130. And then plus A, which is what we don't know, has to equal to 720. Now, there is an expectation that you need to know how to add these by hand, because in the test, because you're also doing integers, chapter 1, you're not allowed to use your calculator. So that's why you do need to learn to add these quickly. Okay, so you got to be quick with adding them. So find your way to add them. I like to find nice whole numbers. So for example, 120 and 130. What does that add up to? 250. So that was nice and easy. And then if you add on with 150, those two 50s make it easier for me. What's 150 plus 250? 400. But then these two we already know. 90 plus 90 is 180. And 180 plus 400 is much easier to work out. 580. Very good. So all I'm missing is I just don't know what A is. But A is the missing amount. How much more does A have to be from 580 to make 720? 240. Wait, no. 140. 140. Therefore, A equals to 140. If you didn't know how, you could have just done 720 take away 580. Okay? And that's how you get 140 degrees. So in order to solve these problems, you need to first know all the interior angles. What must they add up to? That's what this formula is for. Your last question, sometimes they might not want what the total sum is. Sometimes they might just want to know what one angle is. So if you have a look at the last question, find the size of an interior angle in a regular nonagon. What does regular mean again? Amira? Good. All interior angles are the same. So, nonagon, how many sides is a nonagon? 9. So we do 1, 2, 3, 4, 5, 6, 7, 8, 9. I couldn't really draw it properly. But let's do dashes. We're saying all sides are the same. And we're saying all the angles are the same. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 angles, they're all the same. So you're adding them 9 times. A plus A plus A plus A 9 times. 9 of them. So 9 times of these A's needs to equal to. Now, how do you work out the total sum for a 9-sided shape? What do? What should it all add up to? Will? Okay, very good. So this is what we do. Number of sides is 9. 9 minus 2 times 180. And this is where Will got 7. 9 take away 2 is 7 triangles times 180 degrees. Now that's what? 0, 6, 5, 7, 1, 2. So 1,260. That's what the angle should add up to. Okay, so I just did 7 times 0 is 0. 7 times 8 is 56. 6 carry the 5. 7 plus 5 is 12. Yeah? So 1,260 degrees is what all of these should add up to. 1,260. Now remember, what's the question asking? They're saying find the size of an interior. An means one. An interior angle. So they want to know, what is A equal to? So I don't want to know all sum of all 9. I just want to know one of them. So how do I figure it out? Very good. Because you've got 9 of them. You only want one of them. So just divide that number into 9 pieces. And then you know what each piece would be equal to. So A is equal to 1,260. So take the total angle and divide it by 9 pieces. Because you want to know what each piece is. They're all equal bits. So 1,260 divided by 9 should tell you how much one little piece is. Now you can do that on a calculator. You can do it by hand. Let's do it by hand to practice if you get it in a test. So 9 into 1,260. Let's work it out. How many 9s in 1? 0. So you carry the 1. Becomes 12 now. 9 in 12. 1 remainder. 3. Carry the 3 over. So it's now 36. How many 9s in 36? 4. Remainder 0. So then how many 9s in 0? 0. So that means each one has to be 140 degrees. Okay, so if you did 140 plus 140 plus 140 plus 140 9 times, it should equal to 1,260 because you're saying they're all equal. Okay? And that there is the example of what you're doing for 2e. So 2e is just overall 9-sided, 10-sided, 20-sided. You got a formula to figure it out. And then sometimes we'll ask you to find just one angle. Okay? I'll stop the video there, but that's all you need to know. So remember, next week, what is due? What homework am I looking for? C and D. Very good. Triangles and quadrilaterals. That's your goal. Your test should be in week 10, Thursday, shortened lesson. It's a shortened lesson, so it means you got to work pretty fast on it.